Today we are going to be going over the warm-ups for day 1, which covers SOLs 8.1 and 8.2. SOL 8.1 goes through the relationship between fractions, decimals, percents, and numbers written in scientific notation. In addition, it covers mixed numbers, integers, square roots, and improper fractions. Question number 1 says, which of the following is not true? So we are starting with a fraction in each problem. First, we need to convert each of these fractions into a decimal to see if the correlating decimal is true. For this, we can use Desmos. To find what the decimal of 1/4 is, we do the numerator 1 divided by the denominator 4, and we get 0.25. So far, A is true. For B, we do 1 divided by 5, we get 0.2, so that is true. For C, we do 3 divided by 8, we get 0.375, so that is true. And for D, 3/4, we have to do 3 divided by 4, and we get 0.75, which is true. Now we need to look at the percentages. To go from a decimal to a percent, we move the decimal point 2 places to the right and add a percent sign. So for 0.25%, if I move the decimal point 2 times, I end up with 25%. 2.5% is not the same, so this is a false answer. For B, if I move the decimal point in 0.2 2 places, 1, 2, and I fill my empty ocean wave with a 0, I have 20%. So B is a true answer. For C, if I move my decimal point 2 places, I get 37.5%. So this is a true answer. And for 0.75, if I move my decimal point 2 places, I end up with 75%, making this a true answer. We want the not true answer or the false answer, so we would choose A. For B, which value can replace the question mark so that the list of values are in descending order? So if we look at our inequality here, we're given 2 hints. Descending means we're going down, which means that this is the greater value, and this fraction is the lesser value. We're also told by the inequality symbol that says that the first fraction is greater than the second fraction. The easiest way to compare fractions is to turn them into decimals. So let's go ahead and turn 3/8 into a decimal. 3 divided by 8 is 0.375. Whatever we replace the question mark with, when we divide it by 9, it needs to be a decimal that is greater than 0.375. Let's start with 1. 1 divided by 9, 0.111 if we round to the nearest thousandths place. That is not greater. If we try 2 divided by 9, we end up with 0.222. That is not greater. 3 divided by 9 is 0.333. It is close, but it is still not greater. And 4 divided by 9, 444, is greater, so that is the answer that we select. SOL 8.2 has to do with the real number system. Let's start by drawing a quick diagram of the real number system. So all numbers are real, and it's divided into 2 categories. we have rational, and we have irrational. Rational numbers are those that can be written as a fraction. They also include repeating decimals and decimals that terminate. Irrational numbers are numbers that cannot be written as a fraction, and they often are represented as decimals that do not terminate and do not have a repeating pattern. After rational, we have integers. Those are our positive and negative numbers that contain no fractions and no decimals. Then we have whole numbers. That is all of our positive integers, including 0. And lastly, we have our natural numbers, which is the set of whole numbers except for 0. Remember that as we move along the tree, we sometimes fall down. So if the statement goes down the tree, it is sometimes true, but we always get back up. So if we're moving up the tree, it is always true. Now notice we cannot go between rational and irrational. So if a statement involves one of the rational numbers and irrational numbers, it is never true. So let's look here. All whole numbers are natural numbers. So we're going from whole to natural. That's down. It should say sometimes, but it says all. So this is false. The number 0 is an example of a whole number that is not also natural. B, all whole numbers are rational numbers. So this time we are going from whole to rational. We are moving up the tree, so that is always true. So that is a true statement. C, all integers are whole numbers. We're moving down the tree, so that should only be sometimes true. So that is false. -1 is an example of an integer that is also not a whole number. All decimals are rational numbers. Both rational and irrational numbers can be decimals, so this is false. And our answer is B. Number 2, which of the following is not a rational number? A is a integer. It is a negative number that doesn't contain any fractions or decimals. And since integers fall under rational numbers, it is rational. 2/7 is written as a fraction, so it is rational. We can perform the square root of 10 in Desmos. The square root of 10 is 3.16227766. Remember, Desmos is going to cut off the number. So here we have to assume that that number keeps going. And with the exception of those numbers repeating a few times, we do not have a definite repeating pattern. So this is irrational. The square root of 16 is 4. So that is rational because that is a natural number. So the answer is C. 3, which best describes the square root of 181? So first we need to find the square root of 181, which is 13.45362405. And again, we have to assume that this decimal keeps repeating. So that means since it is a non-repeating, non-terminating decimal, it is irrational. In fact, when we have square roots, it is always going to be irrational unless the number on the inside is a perfect square, like 64 or 49.